I want to take a look at a weld with porosity in it and try to do a through wall sizing of the porosity. And this weld does have some cluster porosity right in the middle here. So cluster porosity, what that is during the welding process, porosity or air bubbles can form voids inside the weld. And there's a cluster of bubbles, and they're round, spherical, and I want to show you what the signal looks like. When I do a orbit, I can kind of orbit around these, and I can follow each one of these pores. And I'm using a 60-degree wedge because that helps me interrogate the center. It's good for the center of the weld, the body of the weld. And I'm using a 5 megahertz transducer because the resolution is good. So what we'll do is I'll try to move the transducer forward and catch some of the lower pieces of porosity, and then pull the transducer back from the center line and pick up some of the higher. So let's take a look at that. So right here, this is cluster porosity right in here. This area right here. You can see I'm in my second leg. Here's the ID, or the bottom of my weld. This is the OD, or the top. So right in the middle of the weld, I have porosity. We can see it's a multifaceted signal. Quite broad envelope. But watch as I orbit around. I can take this probe and move it all the way around. Look at this. See how I'm putting it in towards that porosity? I'm going in an orbit, and I'm going around, and I can still see that. So I'm following those spherical shapes in an orbit. So that shows you that it's definitely porosity. It's definitely rounded indications. If this was a crack or a lack of fusion, it would drop off immediately. So let me do this. Let me try to find some. I'm going to push my probe up. I'm going to push the probe towards the porosity so that I will catch some of the lower extremities. So pushing it up, finding some of these. Try to find. That's a pretty good one. Right there's a pretty good one right there. So let me freeze right here. That's a pore, and let me freeze. And it's telling me that from the front of my wedge. Let me see where. Let me on the drawing show you where the wedge is. My transducer. I'm sitting at about a little over 0.9 inches. So if I come onto my plot and I mark just about 0.9 inches from the toe of the weld, that is the front of my transducer. It's telling me that my indication is 1.17 inches. 1.17, right about here. Surface distance from the front of my wedge. Remember, my beam index point and the distance between the front of my wedge and beam index point is 0.25 inches. And so I put the X value in as 0.25, so my measurements are taking from the front of the wedge. So 0.17 and then 0.43 inches down. So right about here, I have a pore. And that's at a depth of 0.43 inches. Now, let me unfreeze this guy. And let me pull back. I'll pull a transducer back, try to catch some of these top signals. So here's my porosity. And there's a pretty good signal right there. Right about there. Let me go forward. Try to catch the top of. Excuse me. Let me go back. Try to catch the top of some of these. So here we go. See, as I pull back away from the weld, I'm coming up and catching the top. So right about there, about, let me freeze this guy. So I'm about 1.1 inch. The front of my wedge is about 1.1 inch from the toe of the weld. So back here, and it says 1.39, and then at the depth of 0.3. So it shows that my porosity kind of in this area right here. That top one I just looked at is at a depth of 0.3 inches. So looking at this, porosity in this area, as I was pushing my probe forward, catching the bottom tip about 0.43 inches, pulling back on the second leg, I'm catching the top about 0.3. So if I take 0.43, subtract 0.30, I come out to be 0.13, 130 thousandths, or 0.13 inches through wall. Let's look at the key. You can see it's pretty close, and we're on the center line. And the technician that inspected this plate said it was 0.15 inches. So we're real close. But as you can see, to orbit around and see those signals, that tells you its porosity.